on we go to the next exercise. We are now, there's 2 more exercises left. We're going to do a second class lever and a third class lever. Now, these have strange positions for the fulcrum. So all the exercises up to this point, the fulcrum was in between 2 masses hanging down. So now the fulcrum is going to be at the very end. And I'm going to lift a mass up, and a mass of 200 grams. I'm going to put it at 30 centimeters from the fulcrum. So if I have the fulcrum at 95, 30 centimeters would be 35 centimeters. So I want 200 grams. So here's my 200 gram mass. I'm going to mass it along with its little mass hanger. And we'll be all ready to go. And then you can calculate the weight. I'm not going to do it for you anymore. You can do it yourself. So the mass on the 200 gram mass plus its mass hanger thingy is 221.9 grams. And that's going to be hung at 30 centimeters from the fulcrum, or at 35 centimeters. So I'm going to put this at 35 centimeters. And of course, it's not going to balance because already it's not balanced. And it's going to be even more unbalanced because of that. So the only way I can unbalance it is to move upward, pull upward on it. But how am I going to do that? So first I'm going to put at 35 here. Show you. I don't know if you can see it. There it is. So I'm putting this one at 35, and this is 200. All right. It's actually not working because it's coming off. So now what I'm going to do is on the right-hand side, I'm going to pull up with my hand, and I'm going to attach this, one of these Olhas meters to the end. Now remember, these are not the greatest things in the world. We did this in the first exercise, how different it was. Now you can see it's not zeroed. So the first thing I want to do is zero this thing. So it hangs, it's still not zero. No. Oh, there you go. Oh, finally. All right, so I am going to attach this thing to the, oops, I'm going to just put it at 95 for, just so we, just easier to put it at 5s. There we go. Now I'll show you where it's at. So now I'm just going to hold it here. See how I've got it balanced? What I'm doing is I'm exerting a torque counterclockwise. You see it's counterclockwise. If I move upward, I'm making the meter stick rotate in a counterclockwise direction, so it's a positive torque. And it's a certain value, so we're going to really quickly read off what it says on there. So it's between 1.5 and 2 newtons. 1.5, 1.6, 1.7. Okay, it's between 1.7 and 1.8. 1.75. So 1.75 newtons, and that's at the 95 centimeter mark. The fulcrum is at 5 centimeters, right? So that means the distance that I put into my torque is 95 minus 5, that's 90 centimeters. So this, I'm pulling upward with a force 90 centimeters from the fulcrum, because the fulcrum's at 5, slightly off. Okay? So I also know that this mass is at 35, which is 30 centimeters from the fulcrum. So we already massed this. Find its weight, multiply it by 0.3, you get that torque. Then you get the torque of me pulling upward on the right-hand side. The only other thing you have to worry about is the meter stick. The meter stick is not balanced. So the meter stick mostly is trying to pull downward on the right-hand side. So where is the meter stick? The meter stick is pulling down at the 50 centimeter mark. So it's as if the meter stick was sitting, you had the entire weight of the meter stick hanging from the 50 centimeter mark again. So pretend the whole weight of the meter stick is sitting at 50 centimeters. Now how far is that from the fulcrum? The fulcrum is at 5 centimeters. So the weight of the meter stick is hanging here, which is 45 centimeters or 0.45 centimeters from the fulcrum. So the clockwise torques, so the negative torques, one due to the meter stick and the other one due to the 200 grams. So there's two torques that are pulling downward on this meter stick. And there's only one positive torque, and that's due to the spring scale. So fill everything in. I'm going to let you try and do it yourself this time rather than me doing it, because we've done several examples with a bunch of these things. Just make sure you add up all the torques that are counterclockwise, add up all the torques that are clockwise. Actually, there's only one counterclockwise torque, and there's two clockwise torques. One is this one, and the other one is the weight of the meter stick right here. So this torque would be the weight of the meter stick times 0.45. The torque to this one would be 0.3 times the weight of this thing. And you add up those two, and that will be your total negative torques, or clockwise torques. That should be equal to the torque of me pulling upward, due to me pulling upward on the spring scale, okay?